Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. As for today, I would like to share with you some subtopic in heat chapter. Hopefully, it's useful for secondary school students, especially for Form 4 and Form 5 students. Before I've forgotten, I'm Farah Hazwani binti Hazaman, a second-year student from Civil Engineering Department, University of Malaya. So I would like to proceed with our first subchapter, which is Understanding Thermal Equilibrium. Heat is transferred at faster rate from hot object to cold object, while remain at slower rate from cold object to hot object. During this process, both objects will continuously release heat or gain heat until they reach an equal temperature. At this state, thermal equilibrium happens when there is no net flow of heat between these two objects. Diagram below illustrates the 3 points that I have elaborated before. Now, moving on to the thermometer. As mercury thermometer is immersed into a hot water, heat will be transferred to the mercury and thus it began to expand. In result, length of the mercury column in the capillary tube shows an increment in reading. Level of the mercury column remain unchanged when thermal equilibrium is achieved, and experience a reduction over a time as the heat lost due to the surrounding. In this process, mercury in the thermometer experiences a contraction. Now I'd like to share with you some advantages of using mercury in thermometer. First of all, high boiling point and low melting point. Second, good conductor of heat. Third, expands and contracts uniformly with temperature. Fourth, opaque where it can be seen clearly and easily. Last but not least, high cohesive force in which it does not stick to the wall of the capillary tube. Now, I'd like to share with you some ways to increase sensitivity of mercury thermometer. As shown on your screen, I have listed 3 tips, which is first, reduce the thickness of the glass tube. Second, reduce the size of the glass tube. Lastly, use a capillary tube with smaller diameter. Now, we're moving on to the understanding specific heat capacity. Heat capacity can be defined as the quantity of the heat energy required to increase its temperature by 1 degree Celsius, while specific heat capacity can be defined as the quantity of the heat energy required to increase the temperature of 1 kilogram of the substance by 1 degree Celsius of 1 Kelvin. Formula is given as Q is equal to mc theta, where Q is the heat energy in joule, m is the mass of the substance in kilogram, and theta is the change in the temperature in degrees Celsius. Now I would like to show you the relationship between heat content and mass. Students carried out an experiment to study the relation between heat content and mass as below. For case 1, a cup which fully filled with hot water is left out for 10 minutes in the room temperature. After 10 minutes, water in the cup is found to be warm. While for case 2, a cup which partially filled with hot water is left out for 10 minutes in the room temperature. After 10 minutes, water falls to room temperature. Thus, it is proven that mass of the substance may influence heat content. The larger the mass of the substance, the larger the amount of heat stores. Okay, now I'd like to moving on to the application of specific heat capacity. So the first application that I would like to show you is sea breeze. Sea breeze happens during the day when the sun hits the surface of the land faster than the surface of the sea, as the specific heat capacity of the land is lower than the sea. In this process, during the day, the land is hotter than the sea as it gains heat much faster. The hot air rises from the land and blows to the sea as it is much cooler. Then cooler air from the sea blows to replace the space left by the hot air at the land and forms convection currents in the air. Note that sea breeze is the wind from the sea. Now I'll let to proceed to land breeze. Land breeze happens during the night when the land cools down much faster than the sea as the specific heat capacity of the land is lower than the sea. In this process, during the night, the sea is hotter than the land as it releases heat slower. Hot air rises from the sea and blows to the land as it is much cooler. Then the cooler air from the land blows to replace the space left by the hot air at the sea and form convection current in the air. Note that land breeze is wind that blows from the land to the sea. Now I'll like to moving on to understanding specific latent heat. Firstly, change of phase and latent heat. Matter can exist in three phases, which are solid, liquid, and gas. Change of phase happens at a specific temperature and pressure. Latent heat is the heat absorbed or the heat released at constant temperature during a change of phase. Specific latent heat is the amount of the heat energy required to change the phase of 1 kilogram of the substance at a constant temperature. Specific latent heat of fusion is a quantity of heat energy required to change 1 kilogram of the substance from solid to liquid without a change in temperature. Specific latent heat of fusion can be expressed as below. Q is equal to mL, where if Q is the heat supply from electrical appliance, Q is equal to Pt, and in result, the equation will be Pt is equal to mL, where Q is heat energy in joule, m is the mass of substance in kilogram, L is the specific latent heat of fusion in joule per kilogram, P is the power of electric in watt, and T is the heating time in second. Specific latent heat of vaporization is the quantity of the heat energy to change 1 kilogram of the substance from liquid to gas without a change in temperature. Specific latent heat of vaporization can be expressed as below. Q is equal to M capital L, and in result, Pt is equal to M capital L, where Q is heat energy in joule, M is the mass of the substance in kilogram, capital L is the specific latent heat of vaporization in joule per kilogram, P is the power of electric in watt, and T is the heating time in second. As you can see on your screen is a cooling curve diagram. Based on the diagram above, A to B is a gas state. The heat release decreases the kinetic energy and the temperature of the gas molecules. B to C is a gas-liquid state. Latent heat of vaporization is released to reform the molecular bonds. The kinetic energy and the temperature remain constant. C to D is a liquid state. The kinetic energy and the temperature of the molecules decreases when the heat is released. D to E is a liquid solid state. The liquid starts to freeze Latent heat of fusion is released to arrange the molecules into fixed position. The kinetic energy and the temperature remains unchanged. E to F is a solid state. The kinetic energy and the temperature of the molecules decreases when heat is continuously released. I hope you enjoyed my video. So hopefully you can use any information in this video for your heat chapter in secondary school and also in upper level. So that's all, and this is the end of my video. Thank you and Assalamualaikum. As you can see on your screen is a heating curve diagram. Based on the diagram above, A to B is a solid state. The molecules are held together tightly. When it is heated, the molecules gain energy and vibrate vigorously. The kinetic energy of the molecules increases and the temperature rises. B to C is a solid liquid state. The solids start to melt. Latent heat of fusion is absorbed to break the molecular bonds between the molecules, but does not increase the kinetic energy of the molecules. Therefore, the temperature remains constant. C to D is a liquid state. The kinetic energy and the temperature of the molecules increases when heat is absorbed. D to E is a liquid gas state. The liquids start to boil. Latent heat of vaporization is absorbed to overcome the forces of attraction between the molecules and also to do work against the external atmospheric pressure. The kinetic energy does not increases. Therefore, the temperature remains constant. Lastly, E to F is a gas state. All the liquid turn into vapor. The heat absorbed increases the kinetic energy and the temperature.